Hi, in this video, we're going to talk about the EIGRP metric. Okay, so EIGRP uses two values, up to 4, but 2 by default, to come up with the routing metric, meaning the value it uses to determine what is the best path. In RIP, there's something called hop count. The number of routers away the destination network is. Lower the value, the better the path. So EIGRP uses bandwidth and actually uses the lowest or slowest bandwidth between the source and destination. We'll talk about this. Delay, the cumulative interface delay along the path, and we'll talk about that in a moment as well. Bandwidth and delay are used by default. Okay. There's also two others, reliability and load. I won't go into these in this video. Maybe I'll do another video that goes into this in a little bit more detail. But reliability and load are optional. And actually, Cisco strongly suggests that you do not use them, that you stick with bandwidth and delay. Okay. And I want to make a note here that MTU, maximum transmission unit, is not one of the values used in the composite metric. It is passed in the routing update, but it has nothing to do with the metric. And I mention this because there was some documentation out there in books and elsewhere that said MTU was one of the parts of the composite metric. Has never been and never will be. Okay, so just want to make that clear. So here's the actual composite metric formula, and you'll see here in this formula, looks kind of strange, I know, but you'll notice that there's nothing to do with MTU. Just bandwidth, delay, reliability, and load. Now, looking at this formula, the Cisco, by default, only uses bandwidth and delay. And the reason for that is on the left there where it says these K values. The K values, by default, only K1 and K3 are set to 1. The other K values, K2, K4, and K5, which have to do with load and reliability, are set to 0 by default. So in the composite formula, the result is that only bandwidth and delay is used. Slowest bandwidth, some of the delays. You can change those K values, which actually change how the composite metric is calculated, and that can include using reliability and load. But again, Cisco highly recommends that you don't modify those values. Okay, let's take a look at how this works. Okay, so what we're going to do is, looking from router R2 at the top here, its path to the 192.168.1.0 network, the LAN of R3. Now, EIGRP uses the information from the outgoing interfaces of all the routers' outgoing interfaces from router R2, and in this case, it's just two routers, R2 and R3. If there were other routers, it'd be all the egress or outgoing interfaces. It uses information from those interfaces to determine the routing metric. So it uses slowest bandwidth or minimum bandwidth and cumulative sum of delay to come up with the EIGRP route metric. Now we would do the same thing from R2 to R1 to R3 and then determine what the best path is. Again, we'll see that more later, actually, when we look at dual. Okay, but let's just take a look at how it determines, assuming this is the best path, to get to the 192.168.1.0 network. So it takes a look at in this case, the two outgoing interfaces. R2's outgoing interface, serial 001, and R3's outgoing or egress interface, gigabit 00. It's going to look at the bandwidth of both of these. Okay? And it's going to see which one is actually the slowest. And the slowest bandwidth is this one right here, okay? The 1024 kilobits per second. So it's going to use that. It actually uses the value in kilobits per second, so it takes the 1024. Now, it has to divide it. EIGRP uses 10 million divided by 1024. Now, the reason why it does that is because it wants to make the metric, a lower metric preferred. Let me say it a different way. 3 hops is better than 10 hops, okay, if we're thinking in terms of RIP. So we want a lower value to be the preferred path. All right, so let's just get back to this here. We look at it looks at all the bandwidth values of all the outgoing or egress interfaces from router R2 to the destination. Okay, the 1024 kilobits per second is the slowest one. So it's going to use that. It's going to divide 10 million by the 1024 and it comes up with 9,765. Okay, actually a little bit more, but it's rounded down to 9765. So I know it's kind of a weird calculation, but let's just kind of keep that in mind. So bandwidth is 9765. Okay, interfaces also have these things called delay values. They're fixed values, and they're really associated with the type of interface. So we can see we have a serial interface and we have a gigabit Ethernet interface. Okay, so with EIGRP, it actually uses the sum of the delays. And by the way, if I didn't mention, you use the show interface command to see these values, both the bandwidth and the delay, and even the reliability and load. You see that there also on the output. But in this case, we're not using the slowest, we're actually using all the delay values. So we're going to add those up. So we calculate the delay by summing all the delays to the destination. So here we have 20,000 plus 10. Okay? And we divide that by 10. And that's just part of the EIGRP composite metric. And we get a delay value of 2001. All right. So let's take a look. We said we're going to take our bandwidth plus delay, and EIGRP does another thing. It then multiplies it all by 256. Glad we don't have to do this in our head, right? All right, so we said our bandwidth was 9765, the slowest bandwidth. Some of the delays, that calculation was 2001. We multiply it by 256 and take a look. That's the value we see in the routing table when we do show IP route. That's the metric. Okay, so we come up with 3,012,096. So that's where that number comes from. So not that you need to have that memorized, but it's the slowest bandwidth, sum of the delay, and that's the little bit of magic. It's really not magic, it's just a calculation, how they come up with this value. All right, so I hope that demystified the EIGRP metric for you a little bit.